Alright, so these warm-ups were quick like I just mentioned. I'm going to be recording y'all's class period. Warm-ups I'll go through fairly quickly and then we'll get to the stuff today. Okay, the first one. You've been doing this equation a lot. And a big thing that you should have learned from this is the fact that it's all over 2a, which is all over the common denominator. So when I'm looking at all over 2a, I can do this. That should be like quickly noticeable to you by now at this point, okay? Because this, immediately, you could see that you could split this up. And putting it in y equals mx plus b, and reducing this 5 to 1/2, C would have been the answer on that. It should have been fairly easy. I would say probably a level 2 out of 10. Okay? The next one is heavily tested on SAT, more so ACT. And it typically will not have numbers these small. Okay? These kind of questions have bigger numbers. So it's up to you to know how to set it up like an equation so that you're not guessing and checking 4 different times until you get the answer possibly. Okay? Here we go. It's all about this word right here. Some of you actually do this, believe it or not, without knowing it, at home when you're like, oh man, what do I need on the next 3 tests to get this C? Or what do I need on the next 3 tests to get this A? Or whatever it is that you're trying to. And a lot of times we do it by trial and error, and it takes forever. Okay? There's an easy way to do this if you know how to set up the equation. If after 4 tests, the average is 75, you should be thinking this. Okay? That means you are adding 4 tests together, dividing by 4 to get 75. So if I multiplied both sides by 4, how much is this even equal to? 300. So we could say like the total right now is 300. Okay? So the next step is, what's the thing that I need to get this new average of 80? Okay, here we go. We know we have 4 of them already taken care of. And we know from the simple calculation that we just did that they're equivalent to 300 points. Okay? How many more? We don't know. If x was 1, that means we just need to take 1 test. If x was 5, that means we took 5 more tests for a total of 9 to get this average of 80. You with me? What am I going to add on top? 100x. Because these are like the same x. If I have 1 more test here, not only do I now have 5 tests on the bottom, but I also just added 100 up top. If I took 3 more tests, I'd have 7 on the bottom, and I would add 300 on top. You see how I'm setting this up? So with this being said, you could quickly with the calculator menu solve feature this thing like this, comma x. Or if it's non-calculator, which sometimes it will be on the SAT portions of the math, you would multiply both sides, you tell me, by what? Nice, 4 plus x. So if I multiply both sides by 4 plus x, these cancel to a form of 1, and I'm left with 300 plus 100x distribute is equal to 320 plus 80x. Okay? From there, all I'm going to do is solve for x. Okay? Basic solving for x. Move this over to get 20. Move this over to have 20. And obviously, how many tests did I need? 1. Okay? So that is your algorithm for those of you who are wanting to use that going forward as far as calculating GPAs and stuff. And if you're good at Excel or Google Sheets, you can even pre-format that to do that for you to where it's a lot easier. Alright, if I scan my answers, which is what you should do always, those things stand out to me. And it tells me, oof, maybe I don't have to do all that work. All I care is that all this multiplied together equals what? Negative. All this multiplied together equals what? Positive. So the answer is B. Okay, I'm just curious, how many of you got all three? Good. Good stuff. All right, here we go. For the new stuff today, again, like I said and as promised, it's not as much and it's easier. Okay? Here we go. So, and you can click on this if you want on your Google Classroom, on your Chromebooks right now, or you can just follow along with me. So, I'll tell you what. Today someone caught a mistake. And the mistake that this person caught, their team was quiet the whole time. They had 0 near the end. And on a big problem, all of us made the mistake, including me. And no one ever raised their hand to correct it, and we just kept going. And finally she's like, I don't think this is right. And then she pointed out the mistake, and I gave her 500. Because we all overlooked this mistake. There were several 2 and 300s today for sure, okay? And again, it's because you're able to put things together, okay? One thing that I'll say, and I want this recorded, is that one person said, I just don't like that I don't have good questions. And here's what I'll say. Whether your question's a 100-point question or a 300-point question, don't try to ask questions that you think are the ones that I want to hear. The ones that were asked that get 300 points are the ones that you're like, man, no one's ever really thought of it that way, right? Don't be afraid to ask those questions. This one person, she was a little afraid to ask questions because she doesn't want to look, quote unquote, dumb. And I tell her, who cares? When you ask those questions, not only could you get a lot of points, but the growth that you make from it is big time. So again, I can't stress that enough, guys. Please don't be afraid to ask what you may think of as dumb questions. Because I promise you, some of them are not. Some of them are really, really in-depth, conceptually understanding. All right, here we go. The fundamental theorem of algebra. What we are looking at is that every polynomial equation that has n is greater than or equal to 1, I'm always trying to lead you to questions, has exactly n roots, including multiple and complex roots. Okay, think about that. When we did this just last class, as far as looking at factors, how many answers from what you just heard or from what you just read on this thing, how many answers would number 1 have? 3. Okay, if you don't see it, keep looking. How about number 2? 3. Number 3? 4, 3, 4, and 5. And this was strictly from what this first statement stated. So today, you will know completely how many you should find. Okay? Here we go. The second part. It says every polynomial of degree n is greater than or equal to 1 has that same amount of linear factors. What does that mean?
Oh, well, I was actually going to ask a question.
Go ahead. What's your question?
I was wondering when it says linear functions, that just means x, but there's not like multiple singular x's. That's just like, or does that mean coefficient?
Okay, so this means when I factor everything fully, all of them will have x to the power of 1. Are there any other questions? Should be. Sometimes you've seen something that looks like that, right? It could be like x squared plus 3 to the power of 1. Is this x squared a linear factor right now? No. Okay, because linear means their power was to what power right here? 1. So, whoa, So yes, that is 2, and here is 1, but ultimately it's x squared. What this is saying is that every one of these will be able to come down to x. You with me? How would x squared plus 3 come down? Setting it equal to 0. Difference of squares, but more so with complex roots. When I have i's, imaginary i's, I can make that happen. Does that make sense? You're breaking it down. Like this right here would be x plus I root 3 and x minus I root 3. That's breaking this down. And notice now the power is 1, just like it promised. Go with me? And they can be complex or real as well. Okay? Last one. Every polynomial will have at least one complex root. If you don't see that right now, that's okay. If you did, that would have been amazing.
If you say it again.
Just read it. So the last one, each one will have at least one complex root. Okay? Think about that, okay? Think about that. As we go through the examples today, I want to see, because this one's the big pointer, if you're able to figure it out. Okay, here we go. So, our first example, and again, asking questions I think is much more in depth than answering questions, okay? As far as how you're processing this. I have this equation equal to 0. Here we go. How many answers will I find? 5. I will have 5 answers. Okay? How should I start? Okay, so we're going to do, wait, someone said it, other people were describing it. It's called the rational root theorem, okay? Write it down in your notes if you need to, because you have to know things by terms for sure, but it's called the rational root theorem. Okay, so from the rational root theorem, this is how we do it. Started from the bottom, right? So that coefficient is 1. The last term goes up top, and now we're ready to find the factors of the top and the factors of the bottom. Anyone, what are the factors of the top? 1, 2, and 4. Okay, here we go. 1, 2, and 4.
Oh, yeah, I was gonna ask, like, so you don't count 2 twice since technically it's like the factors of 4, like 2 times 2.
Yeah, you don't have to count 2 twice. You hear what he said? Okay? So you don't have to count 2 twice. Right now as it sits, you do not have to do that. Yes? Why isn't 3 a factor? Because you can't divide 4 by 3 cleanly. Okay? So it's like what numbers would multiply to get 4? And what Cameron was saying was this 2 and 2. So 1 and 4 and 2 and 2 would give you 4. Remember the rainbow, that way we first started factoring when we first started last unit? That's really what's happening here, but you don't have to write the 2 times.
So when you like plus or minus to get the roots for when you multiply those numbers, you get 6 roots instead of 5.
Yeah.
So isn't that not
Okay, so he's already starting to connect the pieces of where this is all going. Now look, I'll show you right now. Right here, this 1's factor is just 1, right? So you're going to make fractions. You're going to make 1 over 1, 2 over 1, or 4 over 1. Bless you.
Thank you.
And you have the positive and negative of all these. Okay? So positive or negative 1, positive or negative 2, positive or negative 4, which we just write out like this because we're a little bit lazy. Okay? Aaron just said it. We have 6 possible answers right now. 6 possible answers. but there are only 5 that will actually work. Okay? Now look, understand why I'm showing you these analogies, okay? If I looked at 1, 2, and 4, and I was about to go 1, -1, -3, 3, -4, 4, because I'm going to do synthetic division, which number of all of these should we try first? 1. And if it doesn't work, -1.
Wait, but can't you? Oh, wait, never mind.
No, ask the question if you're going
I
there.
was just gonna say, if you technically if you do one and it works, then don't you know that the negative one doesn't work?
Okay, listen. He's saying if 1 works, then the -1 wouldn't work. We're going to answer that question in just a bit. Are there any other questions right now from where we're at right now?
Why are you using synthetic division?
We're using synthetic division because we can't factor this many terms. Look, 1, 2, 3, 4, 5, 6. We didn't learn from all of this right here a way to factor that many terms unless we used rational root theorem. So we have to use rational root theorem. One more question.
So you can't find roots of x with the power of 1, 3. Like when you're you can't factor down and get roots from the equation with the power of 1, 3.
Oh, okay. Here, this is a really good question. This is a really good question, and the timing is good too. It kind of goes with Donald's question just now. He's saying, Aaron just said, if you have x cubed, let's say plus x squared plus x plus 1, here and down is when I think you should try factor by grouping, right? Or if it was just those last 3 terms, you should try breaking it up the way you learned last unit and have been doing this unit and on your homework, or quadratic formula. Okay, here's your answer. Anything that is x to the 4th and up, or 1, 2, 3, 4, 5 terms or more, then we should try rational root theorem. Okay? Good questions and nice timing too. All right, here we go. So here's what I'm going to say. If I said 86 and I said divide that, be honest, what's the first number that popped in your head? 2. 2 was the first number that popped in your head. Because I could break this up into 2 and 43. I promise you, 43 wasn't the first number that popped up in your head. So over here, I know 4 is a factor. But should we try 4 first? No. Because we're trying to break this 86 down, we're going to break it down with the smallest numbers first because it's easier that way. Do you understand? So there is a system to this. You don't want to start with 4, and these numbers can get big. You want to start with the lowest ones because you're doing this all by hand without a calculator as fast as you can, right? Yeah.
Where'd you get 86 from?
I just threw out a number. I wanted you to see what does your brain naturally process. It naturally processes the smaller then to the bigger numbers. Okay, here we go. So we're not going to try 4. We're going to try 1. Okay, and if it doesn't work, then we're going to try -1. Okay, and then we'll try 2 and then -2. Here we go. Put this down in your notes if you need the work. First step, we copy. Then we multiply 1 times 1, right? So these two are going to multiply, and we're going to write that down right here. And then we add. Then 1 times 0. And we add. Right? And then I'll get a -3. Then I'll get 1 times 0, 0 to get a -4. And last but not least, I got the remainder that I was hoping for. That clean 0 remainder, because now I know that this is -4 minus 3x what? Squared. And what's the very first term?
X.
X to the fourth. So this is my factor right now as far as what I have reduced or deduced, however you want to see it as, to where this is a factor, and because this x equals 1 worked, I could write this as x minus 1 as a factor. Okay, real quick, from what we learned just now. Fundamental theorem of algebra says you still have 4 answers here. You have 1 right here. You should have 5 answers. You understand? Yeah.
Where did you get the x to the fourth?
Because when this was x to the 5th, x to the 4th, all the way down to the constant. When you solve synthetic division, no worries, a lot of people forget this, you shift it over to the 1, and there's where your constant starts. Then your x, then your x squared, then your x cubed, and then your x to the 4th term. That's how you build it.
So even though one works, is there gonna be a time or a problem where we're gonna have like both 1 work and 2 or negative 2 or
Yeah. So listen, you have a choice. Be honest. When you are told to factor, does rational root theorem first appear in your head? No. You try quadratic formula, you try number sense factoring, you do factor by grouping, all those pop up into your head, right? So our goal is to find the answers almost like one at a time. So this first one is just, what's that answer right there, guys? 1. And then break this down with other processes, other factoring techniques or strategies. Okay? Here we go. Now, the question was just asked, will you use synthetic division multiple times? The answer is yes. If you are not good at previous knowledge, you'll be forced to want to lend yourself to rational root theorem again. Okay? Now look. Watch what I do right now. You're putting a lot together. X to the 4th, I can break up. To what? X squared. This 4, look at it before you tell me. Should I look at it as 4, 1 or 2, 2? 4, 1. Which one's negative? The 4? Oh. Yeah, that's right. Now looking at this, x squared minus 4 will break up. X plus 2x minus 2. Difference of squares. Your first answer is negative 2. And then your second answer is positive 2. Okay, so over here on our little solutions list, let's go ahead and account for the negative and the positive. The only one in contention that we still haven't broken up is this quote-unquote sum of squares.
Where'd you put that? Yeah, where's the other 2 up there?
Wait, what? Oh, did I erase? Sorry. Thank you. So, right now, I have 3 of the 5. I still need 2 more. And look, because of what we learned today with fundamental theorem, they're right there. Okay? What are those? If I asked you to factor that, x squared plus 1, what would the factors be written as? X plus I, x minus I. If you didn't get that, set that factor equal to 0, subtract that 1, and square root it. Just remember the plus and minus.
So when you say complex root, you mean it has to have an I? Like that's what
Yes, okay. So now we're going toward that question again. Complex roots, the first one is negative I, the second one is positive I, and there you see them. There's 5 answers right there. Oh, I need to put a negative. Who whispered that? Alright,
Wait,
so
it wasn't me.
go ahead.
Bro, what?
so instead of doing a synthetic division for each of the like different possible roots,
Okay, there we're going.
you just use one of them and then you can find the other answers by just one.
There it is. So to me, synthetic division or rational root theorem is the process. Synthetic division is like just the work for rational root theorem. Okay? You're trying to break it down so that you can just factor by hand cleanly. Okay? I want to use rational root theorem as little as possible. Okay? I'm just trying to break these big, huge things down so that it's something that I can recognize and I can just do it by hand. Here's a question for you. When we did it with synthetic division, what happened that allowed me to not do rational root theorem anymore? The two zeros. Did you say that as well? The two zeros. The two zeros happened, which made it a lot easier for me. That's a big one right there. The two zeros as far as the placement of right here and right here. Because there was no x term, there was no x cubed, and now I can treat it, remember we did this last time, almost like this. I can treat it as an a squared piece that almost felt like a trinomial, a normal trinomial. Okay? Alright, so now look. Let me show you something real quick, because some of you can use this and you actually be faster in some ways than the ones who try to do what we just did, by hand. Okay?
Yeah.
Alright. Yes?
Can't you just plug in those factor numbers into the original equation and like solve it?
Okay, here we go.
Like for x?
Oh, okay, look. She's saying, can you just plug in all these 6 into the original and see if they equal 0? That's too much work. Okay?
Or like if you're on a calculator.
Well, these will be non-calculators, what I'm trying to show you and warn you about. Even on SAT non-calculator portions of the math, a lot of people are oh my gosh, they hit a wall when they experience that non-calculator for the first time because they've always been used to calculator. Calculator is allowed on ACT, but it is not on the first part of SAT. And statistically, that's where people struggle the most.
And these are on the non-calculator.
Yeah. Okay, so real quick. 1, 0, negative 3, 0, negative 4. We saw the list of possible answers. Okay? 1 worked. Listen carefully, okay? 1 worked. I have plus or minus 1, plus or minus 2, plus or minus 4. If 1 worked, and I was now reduced to this, which is our answer right here, what number should I try next?
2.
Negative 1. I.
Because you already know negative 1 doesn't work.
Yeah, negative 1. I squared.
Here's the thing. If 1 works, try it again. Because it could be a multiplicity of 2 or a double root. Remember, we've seen this before. If a number is there twice, we just have to write it down once. And you've experienced this when we were graphing and it would bounce off of these roots. You understand? Just like whenever we saw the 86, and what did I tell you you thought of? 2. And the next number you would think to divide this, believe it or not, would be 2 again. And if that didn't work, then you tried something else. Here's an easier example. If I told you to break up 100, you'd say 2 and 50. Then you would go to that 50 and you'd say 225. You see what I'm saying? You try 2 again. So if you're doing that over here, you try it again, and if it doesn't work, then move on to other numbers. Do you understand the point that I just made?
No. What if it's just like this? Okay, if it becomes another. So say that it's like a double root, whatever.
Okay.
Right? So then you would write it so it's like 2 lines, but then would that be like another? Like, why would it matter?
Okay, look, this is a good question right now. X squared equals 0. What we learned today, how many answers should we have? 2. You with me? Which makes sense because if I wrote it out, it'd be x equals 0 and 0. You don't have to write it out twice. But if you wrote it out just one time, it means it's accounting for 2 answers. That's what a double root means. Okay? If you had x to the 5th, how many answers? 5. How many numbers? 1. It just has a multiplicity of 5. So it won't go through, it won't bounce, it'll squiggle. You see what I'm saying?
Yeah.
Are we good? Alright, so let's go to one thing real quick before we move on to, because we only have 2 more examples. We only have 3 examples today, but there's a lot to talk about with these 3 examples. Before I answer another question, look at this real quick that I want to show you. We learned last time, and I'm trying to lead you to that 3 and 500 point question. We learned last time from Descartes' rule of signs. How many sign changes? 1, 2, 3, 4 sign changes. Okay? So positive answers are either 4,
Or 0. Or 1. No, it's 1.
2, or 0, because it starts at 4 because those were the sign changes. It changed by 2 each jump of the way, and it stopped at 0.
So why is it 1?
Because you reduced by 2. That was the Descartes rule. Okay? Yes?
Wait, what are you meaning when you say it changes by 2?
So Descartes' rule, a couple days ago, or last class when we learned Descartes' rule, we had to first count the sign changes and then just go down by increments of 2. Okay?
Oh, it's always going to be 2.
It's always going to be 2. Jumps of 2.
Okay.
Jumps of 2.
Oh, so
That's why I said
it
you're
was
wrong on
5
the whole
and
word.
It'd be 5, 3, 1, and stop. If it was 7, it'd be 7, 5, 3, and
Oh, yeah,
1
so
and
you
stop.
can't go negative. So
You
just
can't
stop.
go negative.
And it would go 5, 3, 1, 0.
Nice.
Is
Yes.
that, okay, is that the answer, the 1, the -2, the 2, and the -5, and the I?
Yes, these right here are the answers. These are the 5 answers that we said we would be able to find. Okay? Here we go. Look. Descartes' rule last time, if I put a negative, please watch because I don't want to repeat this again. If I put a negative x everywhere where you see an x, okay, these are going to give me my number of negative answers that could appear. And if you catch this could be 500 points. Negative x to the 5th would become what? Negative x to the 5th, because negatives to a 5th power or an odd number are going to remain negative. Imagine, I'm not going to write this out because I don't have that much room up here anymore. Imagine, just where x is at, I'm going to put in a negative x. What's negative x to the 4th become? Positive.
It's so subtracted.
But it's still subtracting, so I'm going to subtract that positive. Let's do it again. X cubed will become negative x cubed, but I'm subtracting, so it'd be plus 3x cubed. What's this one, positive or negative as a final answer? Positive. What's the next one? Positive as a final answer, right? Now, if I looked at this and I asked you, how many sign changes did you see? You saw 1. You can't go negative because you're deducing this by 2 as well, like you guys did on the other one. 5, 3, 1, you can't go negative. You remember what I'm saying? So there's only one possible negative. Check this out. There are 2 positives. There's 1 negative.
Yeah, there's a negative I.
Okay.
Oh, but it's imaginary.
These,
Imaginary number.
Descartes' rule only applies to real x-intercepts, the ones that actually hit the x-axis. imaginaries, it does not relate to complex or imaginary. D-E-S-C-A-R-T-E-S. Okay, now look, that's not the 500-point one. Can someone find an error right now?
If you made a mistake in all of this, I
No, I did not make a mistake. It's something that I said last time, and you maybe don't see it now, you'll see it on the next one.
We don't see it now, but when we look.
It's okay. I'm not going to show you where to look, because then I'll give 500 points away.
So is it in the top left region?
I can't tell you where.
Yeah, break it down into a graph. Log to a graph.
Okay, no worries if you didn't see it. Let's move on to the next example, because you can see it on those as well, okay?
Can we get 500 points on those?
Yeah. Any questions right now? There's 500 points on those too. Are there any questions right now?
No, but can you point it out?
So is it only, so it can be 4, 2, or 0, so it's.
It could be 4, 2, or 0 as far as positive ones,
Okay, gotcha.
and only one as negative. These are possible ones, okay? It doesn't have to. Notice it wasn't 4 and it wasn't 0. Yes?
When you're doing the negative signs and like when converting the signs on the equation, why doesn't 3x squared change but everything else changes?
Because the negative becomes a positive x squared, and this is adding that positive.
Okay.
Yes, one more question, we gotta go.
So up there in your answer, there's only one. Well, shouldn't there be a negative with it?
A negative with what?
The 1, because then there's supposed to be isn't supposed to have an inverse with it.
Oh, okay, so he's saying since there was a positive 2 and a negative 2, why isn't there a positive 1 or a negative 1?
Does I change the sign of a, like if you have negative I, does it change it to a positive number since it's I equals
Only
like
I
square root of a negative 1?
If it's negative I squared.
So here's what I'll say. I's happen in conjugate pairs. If there's i's, they have to come in plus or minus. If this said root 2, like the square root of 2, that has to happen in pairs. This 2, it was just coincidental that it happened in pair. It has nothing to do with what you were saying as far as has to happen in pair. Because 2 is a rational number, 1 is a rational number. Remember, the pairs only happen with imaginary roots and radicals, square roots that have weird decimals. Okay, so we got to keep going though. Here we go. Our next one, and you can still see it there, I just got to give you more practice and exposure. Our next one, I'm going to go to the good stuff. I'm going to move everything over and set it equal to 0. Okay, there are 4 terms, and you've been taught if you see 4 terms, try to do factor by grouping. But what were you taught before that? Not standard form, but GCF. GCF out an X. GCF first always, guys. It makes your life easy. And it's another form of breaking it down so that something seems easier to work with. Now, please do not write what I'm about to do. I'm just doing it to show you that it's not going to work. But understand why. Instead of doing 4 or 5 example problems or homework problems, you need to see from this one, okay? I would see x cubed plus 2x squared. Again, don't write all of this. And I would want you to try factor by grouping because there's 4 terms. We were talking about that with a couple questions that we had today. 4 terms and down, factor by grouping. The GCF is x squared. X plus 2 is left over. The GCF is minus 1. 13x minus 10 is left over. Those did not match. And because they didn't match, factor by grouping does not work for this. And Donald, when factor by grouping doesn't work, what do we use? Don't worry. The rational root theorem. Okay? So the rational root theorem we're going to have to use as a consequence of what I just, showed you. Okay? So I'm going to take all of this factor by grouping strategy out, and what was left over in the parentheses, I know now I have to do rational root theorem. Okay, here we go. Started from the bottom.
Now we're here.
Now we're here.
Hey.
The end is 10. Last shall be first, right? Break it up, 1, 2, 5, 10. All over 1. Again, just because this is 1, please don't just think you're just copying this number over. If this bottom one was 20, you would do 1, 2, 4, 5, 10, 20. You see what I'm saying?
Oh, on the bottom?
Yeah.
Yeah.
So it's the same thing, and then you make up all these different fractions based off of just patterns.
Wait, so what determines that number? Is it the multiplicity of the 10?
No. It started from the bottom. It's the coefficient of your leading degree.
I thought it was the root.
It's not the root. It's not the power. It's not the degree. It's the, what is the number in front of your biggest power? 1. And it's not always 1. It could have been 4x cubed. Yeah.
Are we gonna have a question
Yes.
where it has
Yeah.
that?
Yes. So here we go. So this is going to be 1 over 1, 2 over 1, 5 over 1, 10 over 1, aka 1, 2, 5, 10, plus or minus. These are possible answers. We know that the answers, there's going to be 4 answers, 4 solutions, x-intercepts possibly, all that good stuff. Okay? Are we good? All right, so over here, I'm going to take 1, 2, negative 13, 10.
So you don't count the x on the outside?
I don't count this x. This x on the outside, it's already one of the answers. What is it? 0. Because I set each individual factor equal to 0, it's already 0. Some of you made a mistake on the quiz. Hopefully I can get that back for you today. I think I can. If you factored out a 2, some people put 0. What would the 2 need in order for an answer to be 0? It needs 2x. Because if I asked you, you just GCF'd out a 2, and I said, set that equal to 0, how do you solve for x?
You don't.
You don't. You can't, right?
That's the solve.
You still broke it down the way you needed to, but you don't have an answer for that, okay? Just, that's FYI off to the side. Hold up just real quick. So we're going to take these possible ones, and we're going to start with 1. For the sake of saving paper, just look up here right now, okay? 1, we copy, we multiply, we add. We multiply, we add. We multiply, it worked. If it didn't, I wouldn't want you to copy right now because I don't want you to waste a little bit too much time right now because we're running a little bit out of time. But this one worked, okay? That means 1 is an answer. What's left over? X squared. Come on, guys.
Oh,
Plus 3x minus 10. Should I do rational root theorem? No, we can factor this by hand. Some of you already know. What is it?
X plus 5.
X plus 5, x minus 2. What's this answer? Negative 5. And then? Now look. Sign changes. I have 1, 2. That means I should have a possible 2 positive answers. Right? Or what else? 0. You remember how we went down by 2? I have 1 and 2. I have that one. Okay, yeah.
What does the 0 represent in like 2, comma 0 for the sign or the I can't remember how to say it.
I think he's talking at the top left.
Oh, this one?
Yeah.
Oh, these are the positive possible roots. These are how many times could it touch or go through the x-axis. It could either do 2 or 0.
Oh.
And these are from the sign changes. Now real quick, if I did the negative x here, that would become a positive still because 4 is an even number. Negative x would be a negative because it's an odd, but then with this positive, it's still a negative x cubed, 2x cubed. Y'all with me? Y'all see what I'm doing? Hold on just a minute. If I put a negative here, it would become positive, but with this would stay negative. And if I put a negative here, it would become negative. And I have one change. I have one change. So negatives, there could be 1, and that's it. I can't go negative 1. I can't reduce by 2 to a negative 1. Look at this. I have one negative answer. So this one was satisfied, and this one was satisfied.
Didn't you say at the beginning
that
every polynomial function with a degree of n greater than or equal to 1 has at least one complex zero, and we don't have any?
Okay. Ooh, you asked that earlier than expected. She said each one should have a complex solution. Okay? Look, 2 and 0 for the positives, 1 for the negative. Before I get to her question, is there another question or statement?
That's only like 3 answers, not 4.
So here's the thing. Didn't I say yesterday that a shortcut is after you get this 2? If there are 4 solutions, just put a 2 here. I thought I said it. Okay, no worries. Listen. That was the mistake that I was trying to get to see if you could correct, okay? Apparently, I guess I didn't say that. Maybe I said it correctly. So here's the thing. Doing the sign changes, I said that that could be a shortcut. It actually is not a shortcut. Shh. You still have to do the sign changes to see where would I start. This shows that I have 3 possible answers. But that's because 0 is neither positive nor negative. Do you understand? What you learned today, the fundamental theorem says, this is how many answers you're going to have. The Descartes, it says these are the possible positives, these are the possible negatives, but 0 is an exception.
Wait, where did you get 0?
When we GCF this x. The other thing is this. She just asked it. Didn't you say that every single one of these will have a complex root? At least one. There's one in there.
Yeah, no, it's the one.
Listen.
It's the one.
0 is not complex.
The
1
is.
by itself is not complex. Negative 5 is not complex. 2 is not complex.
Okay, so
It's the negative.
You ready? Here we go.
Negative I squared.
Oh wait, forward.
This is complex.
Yeah.
You could have something like 2 plus 3i. That's complex.
yeah.
You could have 2 minus i or 2 plus i. Those are complex. I know it's annoying.
I don't see one of those up there.
Yeah, it is. Look,
I don't
0 plus 0i. 1 plus 0i. Negative 5 plus 0i. It still has a complex piece to it. No, you are not going to have to remember that. No, you're not going to have to put that into the test. I just wanted to see if someone could find it.
So you should do that just to make it look really good.
Because even though they travel in pairs, why does it say at least one? If complex zeros travel in pairs.
Oh, wait, listen. Hey, listen. She just asked, guys, listen. She just asked, why does it say at least one when complex pairs travel? I like the way she said that. Travel in pairs.
because is 0 a rational number?
So my point is, it should say at least 2, right? It should say at least 2 because complex roots should come in pairs per se. Okay? Nice. That's 3. So here we go, guys.
That means there's a question we haven't answered.
Listen. For what you have due before you leave today, and yes, it looks like you have 30 minutes like the other one period did. Your group challenge, you don't, because we did all the stuff that we did today, which to me is more important. On this, you do not have to do number 3. It's your responsibility not to just not read this. Don't just, oh, let me have someone else read it for me and then tell me what are we doing. Read it real quick. Do not use Desmos or you will get a 0 and no bonus points. Okay? Do not use a calculator until the very end of part 2 when it says check and verify with a calculator. Okay? You with me? Here's the only hint that I'll give you on this. Someone asked me before, how do you put a factor that looks like this into the calculator? And I said, you don't. These are imaginary. They're like, well, how do you, if I did this, Lauren had a lot to do with what she just said. Imaginary roots, complex roots come in pairs. We still can't put this in the calculator, but if I were to FOIL this out, we can put that into the calculator. Wow. You have 30 minutes, get it done.
Okay.